All right, guys, we're going to talk about relations and functions. You did this out of the dictionary at the start of Unit 2A. Excuse the bell. We did this in the dictionary, so I just want to go through the vocabulary words because it's going to be important for your examination. Coordinate plane. Coordinate plane is formed by the intersection of two number lines, the horizontal axis and the vertical axis. Hey guys, a coordinate plane is just when the x and the y cross. Coordinate plane is when the x-axis and the y-axis crosses. X-axis is the horizontal axis on the coordinate plane. The x-axis is the one that goes left to right across. It's called the x-axis. The y-axis is the vertical axis on the coordinate plane. Y-axis goes up and down. Quadrants is the four regions into which the x and the y-axis separate the coordinate planes. So we have four quadrants, or four spaces on the graph, in which the lines create four boxes, four squares. You need to remember that quadrant 1 is on the top right side. Quadrant 1 is on the top right side, then it goes counterclockwise from there. So 1, 2, 3, 4, usually written in Roman numerals. So please make yourself aware of that. Origin is the point at which the x and the y axis intersect on the coordinate plane. Origin is always 0, 0. It's the spot dead center in the middle. 0, 0, where x is 0, where y is 0. Ordered pair is a set of numbers or coordinates in which forms x comma y. Ordered pairs. So x comma y, here I have -1 and 5. My x is -1 because x is always first. My y is 5. X coordinate is the x value of an ordered pair. It represents the horizontal placement on the point. The x coordinate is the x value. Right here it's 2, x coordinate. The y coordinate. Y coordinate is the y value of an ordered pair. It represents the vertical placement on a point. So the part that goes up or down. Here with this ordered pair, 0, 6, my y coordinate is 6. Discrete graph is a graph that consists of points that are not connected. Here is a graph. I have a bunch of points. They're not connected. It's called a discrete graph. Continuous graph is a function graph with a line or smooth curve. Continuous graph. Here I have a continuous graph. I have a line with here's a line. Then I have a curve, smooth curve. Relation is a set of ordered pairs. Remember, I told you relation is when it's not a function. When that girl X goes out with more than one Y or more than one guy, right? So the X, which is the domain, cannot have more than one Y, which is the range. Here, I have a relation because I have -1 and 4, 0 and 6, 5 and -2. Domain is the set of first numbers, X values, of the ordered pair. Domain is the x values of an ordered pair. In this list of ordered pairs, I have -1 and 4, I have 0 and 6, 5 and -2. My domains are -1, 0, and 5 because those are my x values. Domains are x. Domains are x's, or aka girls. Ranges are y's, aka boys. Range is the set of second numbers, or the y values, of the ordered pair of a relation. So here my range, in the same set of ordered pairs, my range is 4, 6, and -2. Always, always, always listed in order of least to greatest. So 4 is not first because -2 is a smaller number than 4, so -2 comes first. When listing domain and range, it has to be least to greatest, and you cannot list repeats. So if I had a range where 4 was listed twice, I would only list it once when I list my domains and ranges. Mapping. Mapping illustrates how each element of the domain is paired with an element of the range. So domain, I have -1, 0, and 5. Range, -2, 4, and 6. Due to, if I'm using this list of ordered pairs, I know -1 is actually in an ordered pair with 4. So -1 has an arrow to 4. 0 is in an ordered pair ordered pair with 6, so 0 goes with 6. And lastly, 5 goes with -2. So if I say list these ordered pairs or illustrated through a map, you would just draw 2 ovals, list the D and the R, and then you would connect the domains and ranges. Function is a relation in which each element of the domain is paired with exactly one element of the range. So every girl has a different guy. Every domain has a different range. Should not repeat X values. Here my X is 0, 7, and -3. I don't have any X values that repeat, so I know it has to be a what? Yep, a function. Last page. Function notation. Function notation is a way to name a function that is defined by an equation. So replace y with f of x, or f parentheses x. We went over this in class. Here the example is y equals 3x minus 8, but if I'm trying to write this equation in function notation, I'm going to do f of x equals 3x minus 8. Input is the value that I substitute in for the x value when I'm talking about a function. My input is the number that I'm going to plug in for x. Here my input is 4 because I want to find f of 4. So in this equation up top, I'm going to plug in 4 here for x. 3 times 4 minus 8. This is solving or evaluating function notations. 3 times 4 is 12. 12 minus 8. This is wrong. It should be positive 4. 12 minus 8 is positive 4. Let me correct that. Positive 4. My input is 4. So what this equation says, or this function says, is when x is 4, y is positive 4 as well. Output. The result of substituting a value into a function. Output is the result of substituting a value into a function. So my output is the result that I get out. My output is the answer that I get. So after I input 4, what answer do you get out? And I get positive 4. Vertical line test is what you should be familiar with, right? It's drawing a vertical line anywhere on a graph to see if a graph is a function or not. So here, I can draw a vertical line anywhere and it's a function. Here, I draw a vertical line. If it touches the graph more than once, it's not a function. If it only touches it once, it's a function. So the definition for vertical line test is if any vertical line passes through the graph of a relation no more than one time, it's a function. Okay. Zeros, the x-intercepts of the graph of a function, the points for which f of x equals 0. So the zeros are when the line actually touches the x-axis. Here, here, and here. So on this particular graph, I have 3 zeros of the function. Last 3. Arithmetic sequence, and we'll learn this in a couple weeks, but arithmetic sequence is a numerical pattern that increases or decreases at a constant rate or value. A numerical pattern that increases or decreases at a constant value. Here I have 1, 4, 7, 10. Can you tell me what value it increases at? If you said positive 3, you are correct because 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10. It's a pattern. I could keep going. 13, 16, 19, and continue on. Common difference is the difference, or D is how we notate it, the difference between the terms of an arithmetic sequence. The difference between the terms of an arithmetic sequence. So 1, 4, 7, and 10, we already said that it increases by 3, so the difference is positive 3. And last but not least, arithmetic sequence formula. Again, we'll get to this in a couple of weeks. A formula used to find the nth number of an arithmetic sequence. So this formula is very important for doing that. It's an equals a to the subscript 1 plus d parentheses n minus 1. Hope that you have reviewed your definitions, whether it's for the first time or it's for studying for your exam.